Hello, my dear friends. Welcome back to Booty Aviation Training. As you know, we are doing a series on meteorology now, and this is SK Booty here with today's lesson in aviation meteorology, and that is the different atmospheric layers. So let me tell you right in the beginning that atmosphere is not the same from the beginning at the Earth till the end, till the time you enter space. Right, then let's study what are the different layers of atmosphere. And before that, let's study briefly what is the atmosphere. Atmosphere is a combination of various gases, primarily nitrogen and oxygen, 78 and 21%. And there are some other gases like argon, ozone, etc. And CO2. The ratio of nitrogen to the oxygen by volume is 78 is to 21. By weight, it is 3 is to 1. Now, then another gas present in the atmosphere is water vapor, invisible gas, whose ratio in the atmosphere is highly variable, most variable. It can be as low as 1% to as high as 4%. Some other variable gases are greenhouse gases like carbon dioxide and ozone. And carbon dioxide is 0.03% of the atmosphere. Up to about 80 kilometers from the Earth surface, the atmosphere ratio of gases is more or less same, and it is called homosphere, homogeneous atmosphere. And above that, not a drastic, but there is a small change, and that atmosphere is called heterosphere. Now, we studied in the previous lessons that heat of the earth first is received directly by the earth from the sun, and then it re-radiates and transfers this heat to the atmosphere, and therefore lower levels are warmer, and as you go higher and higher, temperatures fall, and the average fall of temperature is 1.98 degrees Celsius per 1,000 feet, which is 6.5 degrees Celsius per kilometer. And this is called positive lapse rate. And the part of the atmosphere closest to the Earth is called troposphere. The word tropo means turning. 70% of, almost 70% of the atmosphere is the troposphere. As you go up, density of the air decreases, and the molecules occupy the same volume but have less weight. Now, troposphere is the place where most of the weather phenomena occur, like clouds, thunderstorms, dust storms, etc. The reason this is the part of atmosphere most of the water vapor lies. Water gets evaporated from the oceans, rivers, and lakes and returns to Earth in the form of rain, snow, etc. that we will read separately. In this layer of positive lapse rate, temperatures will fall, but there may be some small layers of inversion or isothermal layers in between. Next. After about 8 to 10 kilometers over the pole, above mean sea level, and 16 to 18 kilometers over the equator, temperatures stop falling any further, and temperatures now become steady, and this layer of steady temperatures is called isothermal layer, and it is called tropopause. As per ISA, the tropopause starts at 11 and goes on up to 20 kilometers, and the temperature within the tropopause is minus 56.5 degrees Celsius. Although tropopause atmosphere or temperatures over the equator will be far less because it occurs after 16 to 18 kilometers, right? After that, in the next layer of air, now temperatures which had become steady now remain steady for some time and start rising. And that layer of air from where the tropopause ends till about 50 kilometers is called stratosphere. The lapse rate in the stratosphere is negative, and it is 0.3 degrees per Celsius per 1,000 feet, or 1 degree Celsius every kilometer. Right. The most of our flying is in the troposphere and in the lower level of stratosphere. The lower stratosphere, 20 to 25 kilometers, contains ozone layer. Most of the ozone lies in this range. And also it has traces of water vapor and therefore hardly any clouds and negative lapse rate. Where the stratosphere ends, there is a small layer of stratopause. Temperatures stop rising any further. And then again is a next layer of positive lapse rate. Temperatures will fall, and that is called mesosphere, from where stratopause ends up to 85 kilometers. Then there is a small layer of mesopause. Temperatures stop falling any further and now start rising and continue rising, negative lapse rate, and temperatures become very high. And that is called thermosphere. And part of the thermosphere is called ionosphere, which affects the radio waves passing through the ionosphere, which we will study in radio aids theory in navigation. And where the atmosphere totally ends, although it is becoming less and less and less, and when you find that there is no atom or molecule of oxygen, nitrogen, etc. left, atmosphere has finished, and that happens around 700 kilometers, although not yet defined, and now onwards it is called exosphere. You have exited the Earth's atmosphere. So what keeps this entire atmosphere with the Earth, that it does not fly away in space even when the Earth is rotating? Centrifugal force might throw away all the particles into space. It is the gravity. The force of gravity keeps the atmosphere glued to the Earth. Short and sweet lesson, but very important lesson. And every line in this is a question by itself. Number of questions contained in this. I suggest take a screenshot and study it a couple of times before you go for your examinations. Good luck, all the best. And before you switch off, remember to like the video if you have liked it, subscribe to the channel, and remain with me and wait for the next lesson, which is coming up soon. SK Booty here, wishing you happy landings. Good luck till we meet again. Bye bye.